Welcome to today's discussion session on geology and soil mechanics. So today is our 10th week discussion, and this week we will be uh, starting our uh, chapter of earth pressure theories. Okay, so this week and then next week we will be start solving the problems mostly on the earth pressure theories. In the previous class, we completed the discussion on the shear strength of soil, and in today's class, we will be starting the earth pressure. Okay, and next class will also be dealing with the pressure theory, and in the last class, we will be discussing on the stress distribution a bit. We'll be discussing stress distribution, and then we will be let's see what we do. So maybe we will be revising everything from the beginning till the end. Okay, so let us start today's discussion. Okay, so uh, we are dealing with earth pressure on retaining walls, right? So there are actually three types of earth pressure that can act on a retaining wall. All right. So the first one is our earth pressure at rest. Then the second one is active earth pressure, and the third one is our passive earth pressure. Right. So earth pressure at rest means there is a retaining wall, and that retaining wall is uh, retaining some amount of soil. That soil is actually known as backfill soil. Right? So retaining wall is there; it is retaining certain amount of soil, and there is no movement of the retaining wall. Okay, uh, say this is the wall. Okay, so this is the wall, and soil is there. Yeah, right. So this is fixed here. Say the retaining wall is also fixed at the top. Okay, this might be the case for bridge abutment, right? It's fixed at the bottom, it's fixed at the top. So there is no chance that uh, this retaining wall will move in any of the directions, right? So in this case, the earth pressure which is acting, okay, the earth pressure which is acting on the wall is known as our earth pressure at rest. Okay, now the second case is the active earth pressure. Active earth pressure means, say the wall is actually moving away from the bed. Okay, it's moving away from the bed. In that case, the earth pressure that will be acting on that wall is known as our active earth pressure. Right? So initially the wall was like this, right? Now the wall may be like this, or it might slide here, right? So any of these things can happen. In those cases where my retaining wall is moving away from the backfill, that is, in that case, whatever earth pressure develops, our active earth pressure. Okay. Now, okay, so let me draw this side so it will be like this, right? Okay. Now, this when the soil actually moves away from the backfill, we will see that uh, there is a failure wedge that is formed here. Okay, so it is generally idealized as a what idealized as a planar failure surface, but the actual failure surface is actually a curved one, right? So this soil will actually push this side, right? Push the wall in the this direction, due to which the shear resistance will develop. Okay, so the soil will try to come down, so some shear resistance will develop at the interface. Okay, so this failure wedge, okay, this failure wedge is this actually makes an angle 40 plus 45 plus 5 by 2 with the horizontal in case of active earth pressure. Okay, we will see how is what plus 5 by 2 has come. Okay, and this earth pressure actually acts at an angle delta with the horizontal, where delta is nothing but the friction angle. Say our wall is rough, so there will be some resistive force that will develop at the that will be getting developed at the interface of the wall and the soil. So due to that, what will happen? The earth pressure will act at a certain angle. It will be inclined at a certain angle to the horizontal, which is nothing but delta, and this delta is equal to the friction angle between the soil and the wall. Okay. Similarly, so this was active earth load. Similarly, if the wall actually moves towards the backfill, okay, wall is actually moving towards the backfill, and the earth pressure that will be acting on the wall, that is our passive earth. Okay, now you might be wondering why the this backfill, why the returning wall will move towards the backfill. So there might be many cases, right? So say you have a retaining wall like this. So in one side you have this much soil, and the other side, uh, say you have some any this one. We have soil. So say you have a soil here. Okay, outside. So this side soil is more, right? So this soil will get pushed in this direction, right? So in this side actually we will have active earth pressure, and this in this region we will be having a passive pressure. So this side will be PA acting, and this side will be PP acting. So I will draw it clearly. So this is the retaining wall. Is fixed here. This side, this side. So what will happen? There is a tendency for the retaining wall to act like this, right? So in this direction, we will be having the PA acting, and this direction will be passive action. So in these cases, when where the wall is actually pushing into the soil, that in those cases our passive earth pressure develops. Okay, so there is a development of passive earth pressure. Okay, passive earth. Yeah. In this case also, the failure makes some angle with the horizontal. Here the angle is 45 minus 5 by 2. That 5 is the friction angle of the soil. Okay, friction of the soil. Right? So just the opposite of active case. Now, if you look in this figure, we will see that for the passive case, for this passive force P, to get completely mobilized, you need a large amount of movement of that one compared to the active case. Okay, the active case you need a less amount of in order so that PA is completely mobilized. Right now, you can, if you see here, you will see that this point is actually my earth pressure at rest. It's the P naught. My passive pressure is actually higher than P naught, and my active pressure is actually less than the earth pressure at rest. Okay. Now, if you want to represent this active and passive case in terms of our most factors, so how will it be? So, say, so in first is the case of our first is the at rest case. So at rest case, say you have a soil element, right? So you have vertical stress acting here, and you have my P naught active. Okay, so this P naught at rest pressure is actually lesser than the vertical that is acting. So this vertical, whatever it is acting, that will be my sigma 1 and this will be my sigma 3. So this A circle actually represents that. Now what will happen if you keep on further reducing this P naught, we will reach this PA point. Okay, so this will again be the sigma 3. We are reducing this, so we will reach this PA point. Okay, this will be my active equation. Okay, and these circles, this active earth pressure, and then say, and what will happen in passive case? In passive case, what? Passive case, you have a vertical acting and you have this uh, passive, right? So this passive will be actually greater than this vertical, right? So this one, this will be my sigma 1 and this will be my sigma 3. So this Vp is my sigma 1 and this sigma V is my sigma. So in this case, we will get a this circle E. Okay, circle E. Now both these circles, circle C and circle E. So C is my for active case and E circle is for my passive case. So both these circles will actually actually meet these lines at these particular points. So this line is nothing but my more column failure, right? You'll see that this actually, so the more column failure will actually make a tangent to this line. Okay, and this angle, say, and this these points. Okay, so this will give me the inclination of my failure plane with the horizontal, isn't it? This line, this will be this line which I have drawn now. These lines will give me the inclination of the inclination of the failure plane. Means this plane or this plane with the horizontal, right? So you will see that this comes out to be 45 minus 5/2, so 45 plus 10. Okay, just from the geometry, you will see that this will be okay, right? Now let us see. Now we have discussed that this is my sigma V, and what is my P naught? P naught is actually less than sigma V, right? Pressure at rest is the pressure at lateral pressure at rest is less than by vertical pressure. So this P naught is actually some constant times this vertical stress, whatever is acting. So let us determine this cannot be. So this cannot is actually known as earth pressure coefficient at rest. Right. So what we know, so we can write down that our lateral strain is nothing but from Hooke's law, horizontal minus vertical plus horizontal. Right. You can write down this. This is the horizontal strain, horizontal strain, horizontal stress, vertical stress, and this is my Poisson's ratio. Now at rest means this horizontal strain is actually 0. So from this equation we can write this nothing but 0. So from here we'll get this k horizontal, which is nothing but, what is the k horizontal? Horizontal is nothing but P naught, right? Earth pressure at rest, right? Lateral earth pressure at rest is equal to k naught into sigma v, where this k naught is thing that mu into, okay. Now Rankine gave earth pressure theory. Okay, so Rankine actually gave earth pressure theory for questionless soil. Later it was accepted to C5 soil. Yeah. So in Rankine's case, we had a wall. Okay, we had a wall which was retaining a backfill soil. Okay, backfill soil which has C equal to 0 and 5. Yes, some amount of 5. It is questionless. C was 0. And uh, there was no friction with the, that is, my wall was smooth. That is, there was no friction between the soil and the wall. There was no friction between the soil and the wall. So my delta was actually 0. Okay. So in that case, so this is nothing but whatever we discussed just now, just here, just 2 slides back. We had discussed this thing. So the same thing is actually given here. Okay. So this is my active circle. This is my passive circle. Okay. And you can see that these failure planes are making 45 plus 5 by 2 with the horizontal. Okay. And in case of passive, it's making 45 minus 5 by 2 with the horizontal. Okay. This one is the PP. This one is the PP. Obviously, and this is the PA. This point. Now, how to get my K and KB value? Okay, so from the Moore circle, Moore circle, so you know the equation of the Moore circle, right? Which is nothing but sigma 1 is equal to sigma 3 45 plus 2. What was the equation? Plus or minus, everybody?
Plus.
Plus, no?
2c tan phi. Tan alpha.
40 plus 52. So this was the equation. So for active case, what is my sigma 1? Sigma 1 is nothing but my vertical. And what is my sigma 3? Sigma 3 is nothing but my P active, P active, not P not, P active in this case. Okay, active into 10 square 45 plus 5 by 2. Okay, C is 0 because our soil is question unless we have considered. So what is my PA? PA is nothing but 1 by 10 square 45 plus 5 by 2 into sigma V. So this is nothing but my Ka. So Ka, so Pa is equal to K into sigma V. And what is my Ka? K is 1 by 10 square 45 plus 5 by 2, which is also equal to 10 square 45 minus 5 by 2, which is also equal to 1 minus sin 5 by plus sin 5. Okay. Similarly, in case of passive, my sigma 1 is actually, so what is my sigma 1? Sigma 1 is, in case of passive, sigma 1 is passive, sigma 1 is actually my passive pressure, and sigma 3 is my vertical stress. So my Kp will be nothing but 10 square 45 plus 5 by 2, or 1 plus sin pi by 1 minus sin pi, or 1 by K. Okay. So finally we can write PA is equal to Ka into sigma V, PP is equal to Kp into sigma V, and Kp is also equal to 1 by K. So, like this. Now these are some typical cases. Say you have a dry soil. Okay, we say you have a dry soil. So this is a dry soil. This is a dry soil which is registered, which is being retained by the retaining wall AB. Okay, so this is the, so what will be my PA? So at all the points, say at depth Z, my PA will be small p. Okay, PA will be K into gamma into Z. Okay, so at Z, so this value is K into gamma into the height. Okay, so obviously we'll, so similar, same case with the PP, and obviously we will be getting a triangular variation, right? Like same as our hydrostatic pressure. Similar to that, we will be getting a triangular pressure, triangular variation of stress like this. Okay, so how to find the total? PA will be nothing but the area of this triangle, or PP will be nothing but the area of this triangle. So half into K into gamma into H, half into base into the height. Height is nothing but H. So half to K into gamma into H square. This will be the total. This PA and PP will be similarly, K will be replaced by KP. AP. Okay, these are these PA and PP values, and this will be acting at the height of H by 3, which is nothing but the location of the centroid of this triangle, right? H by 3 at the bottom. Similarly, for submerged condition, say the soil is completely submerged. Okay, say the soil is completely submerged. In that condition, same, just here the unit will be the submerged unit weight. Okay, remember that the unit weight will be submerged, and along with that, we'll have the hydrostatic pressure also acting, gamma W into H. Okay, so these two things are acting when the soil is submerged. Okay, now say we have a partially submerged. Okay, this is a partially submerged case, and also you have some surcharge acting. Okay, so you have a surcharge acting. So first for this part below it's submerged, right? For this part we will be having some hydrostatic stress distribution will be like this. Okay, so this is nothing but gamma W into H2. This is H2, right? This is H2. The hydrostatic we will be getting. Then for this Q, we will be getting a distribution like this. The same, the Q value is same everywhere. So the lateral, due to lateral stress due to Q will be nothing but K into Q everywhere. So it will be a rectangular distribution. Okay. Now let us see here. Let us see up to the height H1. We will having the same as the dry condition. This K into gamma into H1. Right. Now this after this level, from here it is submerged condition, right? It is submerged condition. So say at this point, say you can consider that this part will act as your surcharge. So this gamma into H1 will be acting as a surcharge for this part. It will be gamma into H1 into Ka. Okay, so this part will be fixed. Okay, plus there will be some additional part which will be solely due to this region. The vertical stress in this region is nothing but we'll have a triangular, which will be nothing but H2 into gamma submerged into K. Okay, this part. Right. So what we need to do to determine PA, we need to determine the area of this total, this stress distribution diagram. PW will find the area PQ. So PQ will be acting at half height. This will be H1 plus H2 by 2. This we have to, for the point of action of PA, we need to determine the height, and the point of action of PW, you know, H3. Okay, so after you determine all this, what you can do is you can actually determine the resultant, where the resultant is acting. That height also you can determine by determining the centroid of the combined figure. Okay, so we will solve the problems at that time. It will be clear. So now the next case is our cohesive soils. Okay, so in cohesive soils, what we have, this twice C part. So what also, so sigma 1 into sigma 3 square vertical plus 2 C tan 45 plus 5. So this tan square 45 plus 5 by 2, we are writing this term as n5. It's twice C to 1. Okay. So in active condition, the sigma 1 is particle. This is what? This is my sigma, this one, PA. Right. So what is, so I can write from my PA and phi is equal to sigma 2 minus 2 root over n phi. So PA is sigma B by n phi minus 2 root over n phi. Okay. So you can write this down, write this. And what is sigma B? Sigma B is nothing but gamma into height. So gamma into Z, you can write any height, right? So now say at Z equal to 0. So at Z equal to 0, at which at this point, you are having some negative pressure that will be acting. Okay, the tensile stress that will be acting, which will nothing but equal to 2IC by root over m. Okay, which is shown here. Okay, some negative stress will be actually acting. Now, as you keep on increasing the Z, a point will come when this stress PA, small PA will be 0. And then if you keep on increasing, you will get this point. So, right. So this point is nothing but 9 2Z by n5 minus 2IC over n5. So this is this area. Okay. So if you so ultimately see this and this will cancel out. This and this will cancel out, and ultimately if you take the find the area of this region, that will only give you the PA. Okay. Now this is the case when tension cracks do not develop. Okay, there are two conditions. Tension crack develop and tension cracks do not develop. So if tension cracks develop, say this is the wall. So due to that tensile stress, what will happen? The soil will actually separate from in this region. So these are known as tension cracks. So due to these tension cracks, what will happen? This part actually won't come into picture. So my PA will be the area of this complete triangle. This complete triangle's area will give my P. Say there can be a case when tension cracks develop. Okay, now so sorry, I was saying that when tension cracks develop, this total area will give my PA, area of this complete triangle. Okay, when tension cracks develop. When tension cracks do not develop, what will happen? This part and this part will so this part will come, be acting at that time, right? When tension cracks do not develop. Not develop means the soil is actually at contact with the wall. Contact with the wall means this upper part will be coming into picture. They will be there. So due to that, this part and this part will cancel each other, and the area of this only the below whatever is there, that only that area will give my P. Okay, so tension crack develop. This is the case. This will give you, and when tension cracks not develop, this triangle will give you the this figure will actually give you the PA. Okay. Pi uh, this will be equal to this, right? So this will actually give my P. Now in case of passive pressure, so passive pressure C, so if you do same this operation for passive case, you will see that we are getting passive pressure is equal to uh, let me do it. Sigma 1 is equal to C Sigma 1 is my passive pressure, sigma 3 and 5, right? This gamma into Z, right? This dot and 5. Right? So a fixed amount of pressure, okay, a fixed amount of pressure equal to this much, this much will actually be acting, okay, all throughout the dam for a cohesive soil, for a C5 soil. Okay, this part will be constant, and this is the rest of this part. Okay, this part, right? This sum will actually give. So if you take the area of this complete complete figure substitution diagram, it will be actually giving you the final PPL. Okay, capital PPL. Now say we have an inclined backfill. So in these cases, we are considering that the backfill was actually straight. Now say the backfill is actually inclined at an angle beta. So in that case, my PA will also be inclined at an angle, or PP will also be inclined at angle beta with the horizon. Okay, so the wedge will actually make an angle beta now. So in that case, so this is the value of my Ka and Kp. Okay. Okay, now let us start solving the problem. So I hope this was clear. So as we solve the problems, everything will be more clear. Okay, so let us start. So we start solving the problems. So our first problem is that a 15-meter high rigid retaining wall with smooth vertical back retain a mass of moist cohesionless sand with horizontal surface and following properties. Okay, so backfill is horizontal and it's a high soil, C is equal to 0. The wall is 15-meter high. So these are the properties, gamma and the phi values given. We need to compute the total lateral earth pressure at rest and its location. So we need to determine the earth pressure at rest and the location of the point of action of the earth pressure. If subsequently the water table rises to the ground surface, okay, so before it was dry and moist, and then it is a submerged condition. Okay, okay. So if the water table actually rises to the ground surface, we will determine the increase in earth pressure at rest. So K naught value is given. So K naught is nothing but my uh, earth pressure coefficient at rest. So if say in your question, this K naught value is not given. Okay, so this K naught value can be generally taken as K naught is equal to 1 minus sin phi. So it was given by K. So, okay, so if this value is not given, you can take K naught as 1 minus sin phi. Okay. So, let us see. So, we have a 15-meter high retaining wall, right? 15-meter high retaining wall. Sorry. So this is 15 meters. It is retaining some soil. This is straight. So, we will have a variation of the earth pressure at rest like this. Okay, what will be this value? This value is nothing but gamma into H into K naught. So what will be my P naught? P naught will be the area of this. So half into gamma H into H. So half gamma H square K naught. Let's find out half. What is gamma? Gamma is 16. H is 15 square. 45. So please calculate. This one. Eight hundred
810
kilonewton per meter length of the wall. So 10 strain condition per meter length of the wall. Now say the water table is actually here. Okay, now first let us, so this P naught will be acting at a height of h by 3, nothing but 15 by 5 meter from the bottom. So it will be acting. So now, if the water is actually risen to the top, so then what will be the case? So one variation will be like this. It's nothing but K naught into gamma submerged into height. This value. Another will be due to the water. To the water, it will be nothing but gamma water into height. Right? So this will be P1 and this will be PW. So P will be P1 plus PW. P1 is half K naught gamma submerged square half gamma W. Right. So this gamma submerged you can take this 14 minus and 1. Okay. This you can take
16. It shall be 16 minus 16.
Is it 16? Okay, 16. So 6.1, right? So you can calculate it like this. So let's calculate. Please calculate what will be the value.
.36
1438.36 kilonewton. Okay, kilonewton per meter. Right.
So,
and
water gamma W taken 9.81 or 10?
what did you take?
10. I have taken 10.
Okay. Take 9.81 if nothing is mentioned.
9.8. Okay. So it will change.
Okay, it's okay. So main thing that should be okay, fine. And so due to that water, how much is our lateral pressure actually changing? It's increasing, right? So 14,1438 minus 810. 38 minus 810. So about 628 Newton per meter. So it's more. So see, water is actually, see, due to water, our earth pressure is increasing 600 by 600 kilometers. So water is actually very dangerous. Okay, so water is very, very dangerous. So generally, so that's why what happens. So that way, generally, when returning walls are constructed, so proper drainage, so these seep wells and all, seeping drains, seep wells, and this our geosynthetic drains materials are provided here, so that as a filter and as a for the drainage, so that water can actually easily come down. Okay, because if water is actually, if no filter material is provided, there is no scope for filter the water to come out. It will create tremendous amount of pressure. So when a retaining wall is actually constructed, we provide some drainage equipment in terms of weak wells or So then we provide this so when this is a returning wall, so we provide some this geosynthetic here. Okay, it may be our for filtration. One for the filtration. Filtration means only water will pass and the soil particles won't pass. So that geosynthetic material actually has two functions that it has to satisfy. That is, one function is your drainage and second function is our filter. Is a filter material and is a drainage material. Okay, so generally we provide geotextile here, geotextile for say geotextile for filter, and then one on layer of geonet for drainage. So these things actually we can provide, so that the water does not get stuck. It actually gets drained out. So if water is present, gets stuck there, tremendous amount of lateral pressure it creates. Let's see the next problem. Okay, so retaining wall 10-meter high retains a cohesionless soil with an angle of internal friction 35 degrees. Okay, the surface is level with the top of the wall. Okay, the unit width of the top 3 meters of the hill is this one. The rest of the is this. Find the magnitude and the point of equilibration of resultant active crust. So let us first draw this. So you have a retaining wall. The height of the retaining wall is 10 meters, and it retains a cohesion and surface is level with the top. Okay, so it's level. It's level. Unit weight of the top 3 meters of the fill is, so this top 3 meter, like gamma is 16 ton per meter cube, 16 1.6 ton means 16 meter cube, and the rest 7 meter my gamma is 20 kilometer. So we need to determine the magnitude and the point of application of the resultant active thrust. Okay, so let us first determine our Ka, means active thrust, this coefficient of lateral earth pressure in active case. Okay, it will be nothing but 1 minus sine pi by 1 plus sine pi. Right. So please calculate this one. It will be obviously less than 0.27.
0.27.
Okay. So this is the table. Now see, for the upper part, so this is my wall. So upper part, there will be some, the pressure arrangement will be something like this, right? So let us find what is this value. So this value is nothing but, say, P1. So what will be this value here?
K0 into
Not Ka, Ka.
K
7 into 16 into 3. Right. So it will be how much?
13.
13. Okay. 13 kilonewton per meter. Now 13, right? Now for below this, so this the up to here, whatever vertical stress we have, that will be actually acting as a
Straight.
so yeah straight. So this will actually remain same up to here, right? So directly also you can calculate. So this only the slope, this slope will actually going to, so from 16 this slope will actually change, it will get steeper. Okay, so what is this value?
0.271 into 20 into 7.
Yeah, 0.271. No, this is, you are telling about this.
This triangle, yes.
This one. This one is 52, 2.271 into 20 into 7 equal to how much?
37.94.
37. Now, to determine the active thrust, what we need to do, we need to find the area of this figure, right? So let us do that. So total P active will be nothing but this area. This is half into 3 into this, half into 3 into point 0, 0 point, half into 3 into how much? 13
13.
plus area of this this part. So it will be how much?
7 into
13.
30.
Okay. Then the area of this triangle. Nothing but half into 37.98 into 7.
7.
So please calculate. Half
243.3.
okay, much 243.3.
Yes.
Okay. Unit will be kilometer per
Meter.
meter. Okay, so PA you got. Now what we need to do is that we need to determine the point of application of this point of application of this PA. Okay, where is this resultant actually acting? So for that, what we need to do, we need to find out the centroid of this figure. So it's actually very easy. So let us determine the height from here. Okay, so for this P1, so say, wait, I will just change this and say this PA, total PA is acting at some height. Okay, Y's. Okay, so what we are doing here, nothing but taking the one. So this Y will be nothing but P1. So what is the area of this triangle? This one first, half into 3 into 13. So half into 3 into 13, how much is it? 19.5. So this is 19.5. So 19.5 into 19.5 into
7 plus 3 by 3.
yeah 7 plus 3 by 3, it is
8.
8 plus 7 into 13 91. So this is 91. So 91 into 7 by
3.5.
2. 7 by 2. 3.5 plus what is this much? 7 into 0.30. 132.93. 132.93 into how much? 7 by 3.
7 by 3. Divided by total area. Total
Yeah.
P.
It is 243.3. So how much is it coming? I think it will be close to 3 meters. Three point
2 something.
3.22. Okay. So this is where my this P is actually acting. Okay. So next problem, a retaining wall 5 meter high retains a cohesionless soil with an angle of internal friction 35 degree. The surface is level with the top of the wall and the water table is below the water. Determine the percentage change in the active thrust if the water table rises on the ground. So it's very simple. Just before we solve the same problem for the test case. So but here it's a passive case. So this is our wall. This 5 meters, surface is level. Okay. Saturated humidity is given. So what will make gamma? 20 minus 9.81. 10.19. One second. And gamma. So what is Ka? Just determined same. It was same for the previous problem also, right? 35 degrees. So 0.271. Right. So for the first case, what is this? 0.271 into 5 into 17. So it's a P is so what will be this? Half into 0.271 to 17 to 25, 57.58. The second case is when water is there at the top. So when water is there, we'll have K into 5 into H and 40 to the P is equal to half into K square into H square. So half into gamma submerged is how much? 10.19. So 10.19 into 0.271 square plus 1 to 5 square. So this will be half into 10.19 to 0.275 plus half into 27. So Uh, so we can see that by a large amount our active thrust is actually increasing. So let us determine the percentage increase. 157.14 minus 57.58. 200%. So we get this around 172.9%. Okay, so due to the water, you can see that by almost 173%, our active thrust is increasing. So water is very, very dangerous. Okay, so we have to drain out the water always. If water is there, so there are numerous cases where retaining walls have failed due to this water. Okay.
But in case of underground pit, there is a it will be in rest condition.
Yeah.
So in that case, pressure will be from all both sides.
All sides.
So it will be balanced. So for a pit, it is
For a pit, it is fine.
it is fine. But for retaining wall, it's a dangerous.
Yeah, but for pit also, see, pit inside it's hollow, right? Say it's hollow. Inside, say the pit inside it's hollow. At that time, it's risky. If something is there inside, then it's fine.
Right.
Yeah. Next. So next problem, a retaining wall 10-meter high retain a cohesionless soil with an angle of internal friction 35 degree. The surface is level with the top of the water and water table is below the bottom of the. Okay. There is uniform distributed surcharge intensity over the backfill. Unit of backfill is given, determine the active pressure and its point of application. So here we have the wall. So this is 10 meters. This is level with the top. Surcharge. So surcharge is there. So here you have a uniformly distributed surcharge 63 kilometers. Okay, and gamma is given as 20. So K we already found it out 0.271 for 35 degrees. So due to the surcharge, how will be the variation of our lateral pressure? It will be rectangle.
K into Q.
Yeah, this is K into Q. Q is nothing but 63. And then K into 10 into gamma. Right? So let us find out the total. It will be half into 0.271 to 63 to 10. Sorry, not half won't be there. It's triangles, right? Rectangular area. So 0.2, what is the area of this one? 0.271 into 63 into 10 plus for this half into 0.271 to 10 to 20 to 10. So will be 0.271 into 63 into 10. So 170.70 plus 271. 271.
441.73.
So P is 441.73 kilometer. Now for the point of action of PA, So I is equal to 170.73 into how much? 5
5.
plus 271 to
10/3.
this will be 3 point
3.97 meter.
okay, 3.97. A retaining wall 6 meter high retains a cohesionless soil with an angle of internal friction 35 degrees. G is equal to 2.69. N is given, means porosity is given. Okay. The surface is level with the top of the wall, and the water table is 2.5 meter from the top of the wall, 2.5 meter below. Determine the active pressure per meter length of the wall. So let us draw this. 6 meter wall. Surface is level. Surface is level. And your water table is here. Is here. Okay. So this is the scenario. We need to determine the active pressure, and also a figure actually is not given, so I will give you here. So this is given in the question that is wait. Oh no, yeah, already everything is given. Fine. So this is 2.5 meter. It's told that water table is 2.5 meter below the top. So now what we need to do is that first let us determine the two dry unit weight and the submerged unit weight. So this portion is dry. This portion is submerged, right? So let us first determine the dry unit. So dry unit weight is nothing
G
but
gamma W upon 1 plus E.
so E. How to determine from N? Is the relation between E and N. So N is given as 0.405. So E will be 2.68. So G is 2.69 into 6 into 15.7. Okay, and gamma submerged is G minus 1 by 1 plus E gamma W. .86. Okay, so we got this right. Now, if we want to draw the arrangement, so upper portion it will be like this triangular arrangement. This is nothing but like k into gamma try to how much 2.5, right? And below it's submerged, right? So it will reduce. So I can draw it like this. So this is the top. This is for the top. And what is the pressure? Can you tell me what is the vertical pressure at this level? What is the vertical pressure at this level?
K into gamma D into 2.5.
Vertical is gamma into 2.5,
Gamma
right?
D 2.5.
Gamma d into 2.5. So this gamma d into 2.5 will be acting. Say we can write it like this. So due to this gamma, say we can assume that say this gamma d into 2.5 will act like a surcharge. Okay, so this will be nothing but k into gamma d into 2.5 for this upper portion. Now let us come to this down, whatever this portion is there. For that, we will be having this is nothing but k into gamma submerged to 2.5 minus 6, how much?
3.5. 3.5.
3.5. And also we will be having this water here, right? Gamma w into 3.5. Okay, so we have all these things. So 1, 2, 3, 4. Okay. Okay, so we need to determine the active heart pressure. So let us first determine. So we'll add up, but first is one P1. So what will be P1?
Half into K into gamma D into 2.5 square.
So please calculate this. K, you know, K is 0.271 for 35 degrees. Half into 0.27 and into gamma D is 15.7. 15.7, 2.5,
13.3.
13.3 kilo. P2, P2 is 0.271 into gamma T is 15.7 into 2.5 square. Not 2.5.
2.5 only.
Not
3.5.
3.5.
3.5.
3.5.
14.9. 14.9.
14.9.
15.7 into 3.5. Yes.
In 3.5 square, right? Because
No, no, square will not be there.
gamma D. Okay. 2.5 into 3.5 it will be, right? See, it's correct only. This is K into gamma D into 2.5. So this into 2.5. It will be like 3.5 into 2.5, right?
Yes.
Gamma D into 2.5
37 point.
into 3.5. Yeah. 37.23.
Yes.
Now P3 0.271 into 9.86 half into How much will it be?
6
0.27.
6 kilonewton per meter.
Okay. 16.
No, sorry.
16.37. Please check area of this triangle. This is 3.5.
16.3.
And
That shall be 9.81, right?
and
Gamma
this,
W. It's a 6.
no, it gamma submerged value actually. This value.
Okay.
Gamma submerged we got as 9.86.
Right.
That value. And P4 half into 9.81 into 3.5 square. 60.09. Right?
Right.
Okay. So total will be sum of all these. So what is the total PA? $126.99, right? Absolutely. Okay, 126.99. If we add all these three, P1, P2, P3, P4, total P is this one. Now, let us determine the point of application. Y. So first one will be 13.33. 13.3 into 2.5, 3.5 plus 2.5 by 3.
Right.
Right. So for 13 by 3, 4.33. So 13.3 into 4.33 plus next one is 37.23 plus 3.5 by 3 by 2. 37.3 into 3.5 by 2, then 7.23. Then 16.37 into 3.5 by 3, 60, 16.37 to 3.5 by 3, then 3.09 to 3.5 divided by 126.9. So please calculate this one. We'll also calculate 0.3 into 4.33 plus 37.23 into 3.5 2 plus 0.37.
1.68 meter.
Okay, 1.68. Right. So it's easy if we like separately draw all these pressure diagrams and then do, it becomes actually easy. Then rather than drawing all these thing in one figure, it's easier if we separate all these out. Okay. Separate and then separately draw and then solve. It's quite easy that way. And chances of uh, doing wrong, doing some mistake is actually less. This. Okay. So next problem. Okay, for the retaining wall shown in the figure, find the active thrust and line of action. So see, this figure is given here. 2 layers are there, 3 meters, 3 meters. So what is the thing that is changing here? If you see this figure properly, what is the difference between these 2 layers?
Degree of phi is different.
Phi is different, and upper layer is actually uh, uh, dry, and the lower layer is actually submerged. Okay, so so phi is different means what? So for both these layers, my Ka value will be different. So let us call this layer 1. Right. So this my K values are actually different for these two things, these two layers. So K1, this K1, it will be like 1 by 3, I guess. 0.33, isn't it? How much is K?
So 1 minus sin 30.
0.33.
Right.
K1 and K2 is not, we already find out 0.271 for 35 degrees. Now for the lower, see saturated is given as 19. So let us find out the submerged. So 19 minus 9.51. 9.19. Okay, so now first let us see. So for the upper part, first you will have this kind of variation. Okay, this is 3 meter, then you can move 3 meter. So for this one will be what? K1 into 3 into what is gamma? 16. Done. Now for the second, for the layer below it, so this, so there will be count surcharge here. What will be this? This will be K2. K2 into how much? Can you tell me K2 into how much?
Same K1 into 3 into 16.
K2 into 3 into 16.
3 into 16.
Yeah. And then again we will have one this variation with this. What will be this one?
K2 into 3 into gamma submerge.
3 into what is my gamma submerged? 9.19. Right. And the last there will be water also.
Gamma W into 3.
So again we have this is 1, 2, 3, 4. Okay. So and my P is acting somewhere. Okay. This P is actually acting somewhere at a height, say Y. I won't. Let me not write here. This is 1. This is 2. So this one. P is actually acting somewhere. Just solve. So let us find out P1. P1 is area of this. This is half into 0.33 into 3 into 16 into 3. Half into 0.33 into 3 into 16 into 3. So it will be
23.76.
23.76. And P2 similarly be 0.271 into 3 into 16
13.
into 3, 9 into 16 into 127, how much?
39.
39.0. Then P3 is this one. So half into K2 into 9 point, how much? 19
9.1.
to 3 square. How much is one? 0.5 into 0.27.
11.2.
Per meter. And at last, P4 half into 9.81 into 3. 44.15. Right? Right. So total PA, how much? If we add all this, 23.76 plus 39.02. 118.1. Okay, now what we need to do, we need to find out y. It is the this point of action, right? Point of action. So for that, 23.76 into
4.
4, correct, plus 39.02 into
1.5.
1.5 plus 11.21 into 1, 1, right?
Right.
And 44.15 into
1.
1 divided by 118.14. So let us find out y. 1 point something point
1.7677.
okay 0.77 0.77. Now next, a soil mass is retained by a smooth incline wall of 6 meter height. The soil has a bulk unit weight of 20 kilonewton per meter cube and an angle of internal friction 16 degrees. The top of the soil is level with the top of the wall and is horizontal. If the soil surface carries a uniformly distributed load of 4.5 kilonewton per meter square, determine the total active thrust on the wall per meter length. Okay. Okay, so I will draw the diagram of the this wall that is given in the question. So I will draw that. Okay. Gamma is 16 degrees. So for this case, what we will be doing is that we will be drawing one, we will be converting. So this is my wall. Okay. So this total is my wall. The wall is actually inclined at 18 degrees. So this wall I will be converting it to like this. So this is my wall. X, I will make this imaginary. I will draw this and make this straight. Okay, so this A, B is there. So this is A, this is B. I will C. So what we will be trying to do is that we will be uh, trying to determine the total active thrust on this imaginary vertical wall BC. Then we will, what we will do, will there is in the ABC portion some soil is there, soil will be retained. So that weight of the soil we will take, and that P value we will take the resultant. Then I will take find out the resultant P. Okay. So let us see. So let us first determine the Ka value. So what is the Ka? 1 minus sine 16 by 1 plus sine 16. So what is it? Sine 16 by 1 plus sine 16.575668 divided by 568. Okay. Next, what we do? Next, now what we will do? We will do whatever we have done till now. Okay, just normally usual, our usual case. So for this Q, what? How will be the variation like this? So 4.5 into K. Right. So not 6. Next, due to the soil, there is one triangular variation. This is how much?
K into 20 into 6.
Yeah. K into 6. So this is 1, this is 2. Right. So let us find out P1. P1 will be 4.5
4.5
into
into 0.568 into 6.
yes. $20.44, and P2 will be half 0.568 into what is gamma? Gamma is 20.
That height must be 6 meter.
Okay, 6 meter, right?
Right.
Okay. I wrote it. Just
15.33.
6. Okay. 15.33. And this 20 into how much? 6 square. How much will it be?
204.48.
Yeah. So total PA. So I will write it as PA dash is equal to 15.33 plus 40. How much will it be?
219.82.
Now let us find the resultant. So now let me draw the diagram actually once. So this PA1 is actually, PA dash is actually acting at some height y. Okay, so that y and we are finding out. So 15.33 into how much? 3 plus 204.48 into 2 divided by 219.21. So what is my y? It's 2.707. Okay. That now this wedge, in this wedge soil is there, so this weight is actually acting downwards, right? So in this wedge, so in this part some soil is there. Due to the soil, that soil has a weight, so some weight W is acting downwards. Now let us find this W. W is nothing but half into
6 into
AC into BC. Yeah, the 6 into what will be AC? What will be this? So this angle I know, right? 18 degrees.
sine 18 into
Yeah. So it will be sine 18, right? So sine 18 into 6. So just a second. No, it will be 10, 10, 18. Yeah, 10, 18 degree is equal to AC by BC, right? So AC is BC 10, 18. So 6 into 6, 10, 18 degree. Isn't it? Perpendicular by base, opposite by base. 10 is AC by BC.
right.
So AC is BC 10, 18. BC I know it's 6. So half into 6 into gamma, which is nothing but 20. Into 1, I can take 1, like the per meter width. So width I'm taking it as 1. So out of plane direction, I'm taking it as 1. So what is my weight? Half into 6 into 6 into 10, 18 into 20. So 116.97 kilonewton per meter. So just let me just so this is PA dash, this is my W. So this PA is acting actually here at angle alpha. So what is PA? We have nothing but root over W square plus PA dash square. So please calculate this. So W I know, PA dash I know. At 240, almost 249. 249 per meter. Okay. So we have this. And what is this alpha? Tan inverse W by PA dash I can do. So tan inverse W by 28.02 degrees. Okay. So this was our wall. right? And so our PA is acting here like this. This is Y and this angle is alpha. Okay, so like this we solve this problem. Okay, next problem. An unsupported excavation is to be made in a clay layer. The soil has a bulk unit weight of 18 kilonewton per meter cube and angle of internal friction 16 degrees and C is equal to 30 kPa. Okay, C is given, phi is given. C5 soil. Calculate the depth of tension cracks and maximum possible unsupported depth. Draw the active pressure distribution diagram. Okay, so instead of directly, so let us go from our basic equation. Right. So here tension crack. So this is the active case. Right? So active case. So in active case, sigma 1 is this. This is my P small pa. So you already did this. Pa was what? Pa was gamma sigma V by so P into Z into K over N5. Now it is being asked to us calculate the depth of tension crack. So if you remember for this thing, our distribution was something like this, right? So this is my negative part. This negative part, this is positive part. So this negative part is 2ic. How much 2ic? Root over n5, 2ic. It was, I think, 2ic by n5, right? What was it? We just derived it previously. Let's go back.
2c square root of
We
n5.
derived it. This 2ic by root over n5.
N5.
So this is this negative value. Now calculate the depth of tension crack. Depth of so tension cracks will, there is only possibility of occurrence of tension cracks here in this step, in this portion. So this depth we call let us call it a Z naught. So at Z naught, if you see, my pressure is 0, right? So what we do, we equate this PA to 0. So if you equate this PA to 0 and put Z equal to Z naught, you get like this, right? 0. So from here we will have Z naught equal to twice C by gamma over Ka. Okay, so this will be your depth of tension cracks. This will give my depth of tension cracks. And also the second question is maximum unsupported depth. Maximum unsupported depth means there is means total, if you add everything, all the pressure, there is resultant pressure is 0. So the soil can actually stand by its own. So depth is actually this side, which is 2 This is the maximum unsupported depth up to which the soil can stand by its own. Stand by its own. Why? Because there is no earth pressure, right? So soil is actually stable there. It doesn't need any support. It can stand by its own. Okay, till that depth. So first, let us just determine this depth of tension crack. So Z naught is okay. So what is my K? It is given as 10 degrees. So 1 plus sine 10 degrees. So it will be 0.704. Okay. And so do I see gamma is given in the question as 18. Gamma is given in the question. What is C? C is 30. So please calculate this 2 into 30 divided by 18 into root over 0.704. 3.973 meter. So this is the depth of tension here. Now calculate the maximum possible unsupported depth. Okay, so the maximum possible unsupported depth is nothing but this is depth of tension curve. So next is maximum supported depth. Maximum possible is nothing but 2 into Z naught. 2 into 8 Z naught. So if my depth of excavation is less than 7.95, then the soil can stand by its own. Right? It doesn't need any support. An active earth pressure distribution we already do, it will be something like this. So say unsupported depth. So this say this depth is 7.95. So my active earth pressure distribution will be like this. This is minus C. Right. This is plus C. Okay. Yeah. Just a second. I will check one. Just check one thing. So this value, let us find it out. 2 into 30 divided by root over n5 means 10. 45 plus 10. So 2 into 30. 34.65. Oh, sorry. Mistake. Then what it should come. It should come. Okay. Angle I made mistake. Na? 50, yeah. So it's coming 10 by 2 as 50.34. And this is minus 50. Okay. Next problem, a smooth vertical wall 4 meter retains a cohesive soil backfill with a bulk unit weight of 18 and an angle of intersection 0. So phi is 0, C is there. Calculate the depth at which earth pressure is 0, means Z naught. Again, that Z naught we have to find out. Depth of tension crack or depth at which total active thrust is 0. Okay, means twice depth of which total active thrust is okay. Total active thrust per unit length of the wall when tension cracks do not develop. Okay, and draw the active pressure distribution diagram. Okay, so one by one let us solve this. First, see, first my phi is what? Phi is 0. So what will be K? 1 minus sine 0 by 1 plus sine 0. What is sine 0? Sine 0 is 0. Right, so K will be 1. Now, see, this is my diagram. This is my wall. This is 4 meter height. 4 meter height. Now, so since some C value is there, so how will be the variation of my active earth pressure? It will be like something like this. And on what is this height? What is this height? We just calculated this. What was that? 2IC by gamma root over K. 2IC gamma root over K. So what will be this? 2 into 10 by 18. So 1.11 meters. Right. And what is this value? What is this value?
To see
Root
upon
over K. 2IC root over K. So what is that? It will be 2IC only. Right. 2IC by n5. So it's 2IC only. 2 into 10, 20. This is minus. So 20. 20, right? And what is this? This value, can you tell?
K into
K into gamma into H minus 2IC root over K. Right. So what is this? How much will be this? 1 into gamma is 18 into 4 minus 2 into 10, 52. Okay. Now, first we need to determine the depth at which my earth pressure is 0. That we already depth at which EP is equal to 0 is 1.11 meter from top. Right? So we only determine this here, earth pressure is 0. Next is depth of tension cracks. Same depth of tension cracks. Nothing but same 1.11 meter. Done. Next is net active thrust. The location where the net active thrust is 0. So net active thrust is 0 up to what depth? Here. So here is negative, here is positive. So up to this step, twice and not this H step is 0. Let me write H naught. So this H naught depth, this total active thrust is 0 when the tension cracks do not develop. Right, because negative and positive are cancelling each other. So the net active thrust up to this step will be 0. right? So let us, what will be H naught? 2 into Z naught, 2.22 meter. Now the next one is see the active pressure diagram. So we already made the active watt pressure. Now let us find out the active earth pressure, the total active earth pressure. So now let us calculate the total active earth pressure that is acting. So what will be this? It will be just the area of this figure, this portion, right? Because here negative positive it will cancel out, and this region we will get, isn't it? So this trapezium's area we have to find out. So what will it be? Half into sum of parallel sides is 52 plus 20 into what is this height? 4 minus 2.21, 4 minus 2.22, 1.78 to 1.78. So total will be half into 72 to 1.78, 64.08 kilonewton meter. So this is the total active thrust. Now, what would have changed? Can you tell me if in the question there was the tension cracks develop? Say tension cracks do develop. In that case, what would have happened? These portions, how to show it? Just see. In that case, this portion would not have been there if tension cracks would have developed, right? Because there would be a separation between the wall and this soil crack. So due to that, what would happen? This negative portion would not have caused any effect on the wall. So because of that, at that time, if you are asked to find out the PA will be nothing but the area of the this triangle. Okay. But in this question, tension cracks do not develop. So this negative will be actually there. So negative positive will cancel out, just a trapezium will give a total P. Now, okay, please find out the line of action of this active thrust. So this is just, you use the area from the formula for location of centroid of a trapezium. We can have this y is equal to 2 plus 2 by 2 plus 22. So 0.758 meter from base. So this PA, the net PA is actually acting here. Can height of 0.758 meter. Okay. So this is how we solve. Let's go to the next problem. So problem 10. Yeah, now this is that case. Now this case is the same as the previous problem, but here tension cracks similar to the previous problem, but here the tension cracks develop fully. Okay, so here our tension cracks will develop. So In that case, how do you solve?
Area of complete triangle,
Yeah,
bottom triangle.
yeah, bottom triangle. So let us do that. So, I- so this is 5 meters. So what is Z naught? Let us find it out again. What was Z naught? 2IC by gamma root over Ka. What is Ka? 1 minus sine 20 by 1 plus sine 20. How much will it be? Zero 0.49. Okay. Okay. K will be 0.49. So Z naught is how much? 2 into 30 by 18 into root over 0.49 is equal to 60 divided by 18 into root over 4 point.
76.
Yeah. So this is actually large. So if I redraw this, actually like this. So this is Z naught, Z naught negative. This is positive. Okay. So this upper portion won't be there. Only the lower portion will be there. Right. So what will be this? K into gamma into H minus 2IC root over K. So how much? So K is how much? 0.49 into 18 into H minus 2IC root. Find it out. 2.1 only. Very less. 2.1. This portion. So this PA, so tension cracks do develop, right? So this upper portion won't come into picture. So we will take the area of this complete triangle. So my PA will be half into 2.1 into this side. What is this side? 5 minus 4.76, right? Is 0.5 to 2.1. So 0.252 penta. So PA will have here. This is nothing but 5 minus y. So y is nothing but 5 minus 4.76 divided by 3. .08. Okay. So is it clear? This one? Clear, right? So the upper portion we are just not taking into consideration. The bottom area of this bottom triangle we are taking. Okay.
Yes.
So we will solve one more problem, the last problem. This will be the last problem. So A smooth vertical wall, 5 meter, retains a soil backfill with a bulk unit weight of 18 kilonewton per meter cube and angle of internal friction 12 degrees. C is equal to 15 kPa. Okay, and the backfill surface is horizontal. Okay, plot the distribution of active pressure on the wall. Determine the depth of tension. Okay, all those things we need to determine. C5 C5 soil is there. Okay, so let us first step is determination of K. So first let us find out K. One minus sine two over one plus sine two over 0.656 and okay, now what we need to do first thing is plot. Okay, plot letter. So plot will be like this only. So first let us determine Z naught here. What is Z naught? 2IC gamma root over K. So please find it out. 2 into 15 by 18 root over 0.656. It is Z naught. T divided by 10 into root over 0.656. 2.06 meters. So 5 meter wall. Sorry. How much was it? Do I see?
Upon square root of
Do I
alpha.
see? Do I see root over K, right? Okay. This one was gamma into K into H. This F naught is 2.06. Determine the magnitude and point. Okay.
That value, I think it's a 2C square root of
K, right? 2
A
into
2C upon N phi, I guess.
yeah, 2 C upon N phi is see 1 by N phi is root over K. Same.
Okay.
Same only. Okay. So this one is this. Sorry. So this one, if you calculate, is 24.29 kilonewton per meter square. And this down, if you calculate, it will be how much? Gamma is 18 into K 0.656 into H is 5 minus 2 into 15 into root over 0.656. 34.74. This is positive. Now, say there is formation of tension cracks. Okay, so say there is formation of tension cracks. So if formation, then what is PA? What will be my PA? The area of the lower triangle, right? Nothing but half into 34.74 into half into 34.74 into total height, which is 5 meter minus z naught 2.06. Tension crack formation is there. Okay. So half into 34.74 into 5 minus 2.06. 51.07 kilometer per meter, and height not highlighted, point of action. Point of action to 5.2.06 by 3 into 4 divided by 3 from base. Okay. Now see, let us come to this. So determine the intensity of a fictitious uniform surcharge which is placed over the backfill, which can prevent the formation of tension crack. Okay, so say we have a fictitious surcharge. What fictitious surcharge do you have to place over that so that this negative portion actually doesn't come? So what do you have to do? So for no tension of the at the top, see, for no tensions, this we need to have some fictitious charge. So for no tension, what should be the case? At the top, there should be no tension. No tension means whatever surcharge we place there, whatever surcharge we place here at the top, that should cancel this 24.29, right? Because it's negative, isn't it?
Right.
This 24.29 is negative. This should be cancelled by applying a surcharge. So K, let Q be fictitious surcharge. So K times Q should be equal to this 24.29. So this Q is nothing but 24.29 divided by 24.29 divided by how much? 0.656.
0.656.
So 37.03 kilometer per meter square. 37.03. Okay, so now in this case, what will be our this PA? So now what we are doing is that this is the case. So here we are playing a surcharge equal to 34.03 square. Okay, now say this is not there. If it was not there, I would have got something like this. Right. So this one we already calculated as 34.74. 34.74 we calculated this, right? Say this is not there. This portion is not there. So this was our case. Just I'm drawing this diagram again. This thing I'm just drawing again. Okay. This was the original case, negative, positive. Now again we are adding this. Now we will just get along with that, we will get this. So this is how much? 34.03 into K. Right? Now, if you want to find out the total pressure in now, the new changed active water pressure, what will it be? It will be just the area of this. What is the area? 34.03 into 0. How much?
0.656.
656 into the height. Height was 5 meter. Right? Plus this area, whatever we already calculated, 51.07. this area. Why we are doing 51.07? Because this portion now it is not developing, right? The upper portion is not developing. Negative portion is cancelled out, totally cancelled out due to this this application of this. So 656 into half. So our total will be half into 34.03 into 0.656. Just I've done a mistake, not 5, it won't be 5, right? Okay, this won't be 5. What is this height? 5 minus 2.0, what? How much is that? Not 2.06,
And now,
2.94.
now height shall be taken up to ground, no? Because negative pressure came back and bottom pressure 34.74 as it is.
Negative pressure, it's getting cancelled out.
So there will be
Because
0. From 0 to line will be connected to 34.74.
0?
Top 0 and bottom 34.74. Due to
Okay, you are
additional,
saying that. Okay, okay,
Bottom
okay.
will
Let
be
us.
added. Bottom will be added.
Okay, okay. Yeah,
Like
yeah, yeah.
bending
Bottom will,
split.
yeah. See, let us see. Let now see now what will be my PA equation. Let me write my. So before, what was the PA? Gamma into it. Let me gamma into K minus 2IC root over K. Gamma into Z into K minus 2IC root over K plus Q into K. Right? This is my small PA equation. So here at Z equal to 0, let us say at Z equal to 0, what is PA?
minus.
This is 0. This term is 0. These two are equal. So at Z equal to 0, PA is 0.
Right.
Okay. Now at Z equal to Z naught, let us see what will it be. Z equal to Z naught. So Z naught was how much? 2.06. At Z equal to Z naught. 2.0. So put 2.06 in place of Z. Let us see how much PA we are getting. So gamma is 18, right? 18. So 18 into 2.06 into K is 0.656 minus 2 into C is, what is this value? 24.29 minus 24.29 plus Q into K 34.03 into K, what is K? 0.656. Yeah, so just this part will be coming, right? At Z equal to Z naught, why this portion is 0? Isn't it? So up to this level, only this part is coming. So completely this part we are getting 0 only, right?
Okay.
Just from here you will be getting some value from this below Z naught portion. This portion is not coming into consideration. So here also see, you just calculated it. Here we are getting 0. Here also we will be getting 0. Isn't it? At Z equal to Z naught, we know that this is 0. Just this portion will be there. This part. Due to this. So this part of the equation will be 0 for this total depth Z naught. Only this will be there. The surcharge part will be there. And below Z naught, this will also come into play. This and this will also come into play. Okay. So if there is any doubt, what I suggest is that you take Z, say Z at a gap of say 0.1 meter, and then you put Z. See, First you put z is equal to 0, then you put z equal to 0.1, then 0.2, like this. You can do it in an Excel sheet, right? You have the equation, just take z values and just find the PA pressure, then it will be clear. You plot all this, then you will see how your variation is coming. So just you can check.
Okay.
Okay. Okay, so total area will be how much?
Here half into 34.03 into Ka.
34.74 it will be, I think.
Right.
74. Yeah. 34.74. Okay. Yeah, I was saying 2.94. So half. So not, see, K won't be there. This I have already calculated by. See, I will just write this again. PA is equal to half into 34.74 into 2.06 minus 2.94 plus 34.03 into K into what is the total height? 5. So this will give my total thrust 172.474 meter. Okay. Okay, so this part you understood, I guess. So because of the QC, that this part, my PA, see, if I ignore this portion, for PA, my changed equation will be this one at any point, just not this plus this. This will give the PA for this plus this plus this. So this first portion is for this one, and for this one, we have this one, right? So at any point, if you calculate, you will see that just the just this part will become the what it is taken is that for just for up to the depth z, not only the effect of our surcharge is taken. Okay, because we are saying that at the top we are nullifying the tension, so that tension negative part won't develop. This is what we are saying. Okay, so that's why we are saying that this top portion will develop, not develop, because we are placing this.
So in this equation, there shall be Q into K into Z.
Q into K into Z, why? Q is same only, na? Q is not varying with Z.
Right. Sorry.
Q will be same only. Okay. Okay, so this with this problem we will and today next today we will not solve any problem regarding our passive earth pressure and all, right? So next class we will be solving the passive earth pressure problem, and we will be solving some problems from Coulomb's theory. Okay, if possible, like not Coulomb's, actually from not from Coulomb's, just where there is some friction between the wall and the soil. We'll consider that and we will try to solve some problems. Okay, so we will end today's class. So thank you.
Thank you.
Thank you. Good.
Thank you.
Good night.
જેવી કઈ ચીજ છે જે ઘણા બાળકો ખાય છે પણ કોઈને સારું